All right, the next exponential function we'd like to investigate is radioactive decay. Many times we're wanting to know something about this equation, which looks a lot like our other exponential equations. A final equals A initial e to the negative lambda t. Okay, let me make that t a little bit better here. Okay, where activity final is the activity after time t of decay. Activity initial is the original or initial activity before the time that we're considering of decay, before time t of decay. Lambda is known as our decay constant. And decay constants have a very interesting unit. They are in units of per time or inverse time. So time, some sort of seconds, minutes, or something to the -1, or known as per time. And t is our time of decay. All right, so again, we ought to be able to solve for any of these different variables. And for this example, we're going to use something that's very much real life. And we're going to look at how much radioactive substance we need to produce at a radiopharmaceutical facility or some sort of radioactive production facility for a customer. Let's say that a certain researcher at the University of Virginia wants to have a sample of 3.5 curies of phosphorus 32, P32. P32 is a very common isotope used out in research in the industry. And so they want this 3.5 curies of phosphorus 32, and they want it at the University of Virginia Monday morning at 9 a.m., 0900, 9 a.m. So phosphorus 32, one of the things we have to concern ourselves is it's a radioactive substance, so it's continuously decaying away. It may have 3.5 curies a day, but by tomorrow it's going to have less than 3.5 curies because it's getting less and less all the time. So if we take a look at P32, we need to know something about how fast it radioactively decays. And how we do that is we go look in the chart of the nuclides. So looking in the 16th edition of the chart of the nuclides, and we look up phosphorus 32, and you can either look in the very back under the alphabetical listing and find out phosphorus has an atomic number Z of 15, and then go to the numbers on the side of 15, or you can just say, hey, it's got a mass number of 32, and start flipping through the pages to where a bunch of the isotopes end in 32, and you'll find P32. And right underneath the symbol P32, you'll find out that it says 14.28D, which is the half-life, okay? The half-life. So that stands for 14.28 days. And the half-life is the time that's required for the radioisotope to decay to half of its initial amount. So basically in 2 weeks, if you have so many grams of this stuff, in 2 weeks, half of it's gone. Or if you have so many curies of it, much of the stuff, in 14.28 days, you only have half of it left. Well, you say, well, you've kind of gone off here and got away from your equation here, Bruce, but I haven't, because one of the ways that we define decay constant is that lambda, the decay constant, that inverse time, is equal to the natural log of 2 divided by the half-life of the substance of whatever you're talking about. So in this case, if we want to know the decay constant for P32, we got to take the natural log of 2 and divide it by the half-life that we looked up in the chart of nuclides for P32. So natural log of 2 is approximately 0.693, or you could actually punch it into your calculator. And we said the half-life of phosphorus 32 is 14.28 days. Notice no units in the top, and we have units in the bottom, so it's going to end up, we're going to have some sort of number. When we take 0.693 and divide by 14.28, you'll have a number, and then your unit will be in the denominator, so it'll be per days, okay, or inverse days. So we do this, we find out that 0.693 divided by 14.28 days gives us 0.0485 inverse days. And that's our decay constant, our lambda. So what do we know? We know what's our final activity. Okay, so put a little check mark over final activity. We know that the researchers, after this thing decays, we want 3.5 curies of it. We don't know what the initial activity is. I'm going to give you a little more information, and that's what we're going to be solving for here. We found out what our decay constant is, and how long is it going to be from the time of production of this phosphorus 32 to the time of actually using the phosphorus 32. So since a lot of these production facilities work a Monday through Friday schedule, we're going to say that if they ordered on Monday, and by time travel and everything, we're going to say they produced it, let's say, Wednesday, and we're just going to say